Hello, good afternoon, or good morning, or good evening, wherever you are in the world. Test, test, 1, 2, 1, 2. Can you guys see me and hear me okay? Check, check, 1, 2, 1, 2. Got a yes from Alexia. Adiksha, and I apologize in advance if I mispronounce anybody's name. Don't be shy about correcting me. Funmi, Derek, excellent. Yeah, so welcome. Welcome to this free session, and we're going to get started. And I am Rich Zwelling. I've been doing the GRE. Actually, it's just more than a decade, but it's actually more than 15 years now, believe it or not. So I've been doing this for quite a while, the GMAT too. I love discussing these problems with students, and I welcome you to my class. It's going to start on next Tuesday, and I'd be excited to have you. It's 40 hours of live instruction, 2 hours at a time, twice a week. And we go through the entire course from top to bottom pretty much. And I like it to be interactive. I like you guys to ask questions, and I like to kind of put my own spin on things. So it's not just kind of the TTP course and repeat. I like to put my own spin on things. So where's everybody signed in from, first of all? You should got a pretty good spread around the globe. Hi, Sophia. Oh, Lebanon, India, great. Lagos, all right. I am in Houston, Texas. Anybody else? Hello, Joshua. Mexico City, all right. So far, all international. All right. Cool. Well, let me know where you're hailing from, where you're signed in from, and we will get started. And I wanted to focus on the quant side, some inequalities and absolute values, and also for the verbal side, doing some critical reasoning stuff. I tend to do on verbal stuff like text completion, sentence equivalence in the past, so I kind of thought I'd put a new spin on it, do some critical reasoning. And I kind of wanted to get started to see what you guys think about this initial problem. We're going to kind of walk through this one together to see where we're kind of where we stand. So let me get this first problem up. There we go. Hopefully you guys can see it okay, but let me know if there are any problems. And the first thing I wanted to do is kind of cover the quantitative comparison question. If you've never seen this before, if you're new to the GRE, you're going to be given two quantities, and your job is to decide which one is bigger, or are they equal, or can you not tell? Pretty simple, right? The answer choices are always the same. You see them in the bottom left. Pretty self-explanatory, and you're usually given some information at the top. So there's some information we're given. We got two inequalities here at the top, and your job is to kind of take those and say, okay, well, can I determine if one of the quantities is bigger or smaller? And one of the things I often like to tell my students is, don't forget that D is a perfectly valid answer, right? So the answer, oh, whoa, that is way too small. Let us change that font. The answer might be D. You have to take into account that maybe you can't tell. So always have that answer in mind, because I think what some people have a tendency to do is they can't tell and they panic and they think they did something wrong. But in actuality, you might have done everything right, and the answer is legitimately D. Okay, and I'm also going to allow you guys to come on the mic if you want to. So I will allow you guys to unmute yourselves if you want to hop on the mic and tell me what you think. But yeah, I wanted to kind of unpack this question and see where we would get started. So I have these two pieces of information. What can I do with them? And again, I'm not looking for the final answer, just kind of a first step. And let's see, who else we got? Hi, Sweta or Sweta, Henry. Like I said, don't feel shy about correcting me if I mispronounce your name. And any thoughts as to how we would get this problem started? And you could say, I don't know, that's perfectly fine as well. So somebody's saying we can isolate A or B to the group. So Alexia is saying that, isolating A or B, great. And what does that look like exactly if I treat it algebraically? So we could do something like that. We could say, all right, 5a all divided by 2 is greater than b. So just taking that first inequality and we just divide it by 2. And then we say, okay, well, how does that help us or how does that not help us? Could we take that in a different direction? Any ideas? Well, one thing we could do, let's see if we actually take that and look at the second inequality and do something kind of similar, right? It says that 4a is less than 2b. So what if I do the same thing that Alexia was saying earlier and say, okay, well, I got 4a divided by 2. So I just divide both sides by 2. And I get that 4a divided by 2 is less than 2b, which effectively means, 4a divided by 2, that's going to be 2a is less than b. Okay, so then I would then look at that and say, okay, well, what road does that lead me down? Can that help me in any kind of way? Well, one of the things that you can do with inequalities, and I think a lot of people forget this, but you can flip them. And not only that, but visually, you can really stack them and start to see what the relationship is. Because if I do that, I realize that I have kind of a connecting thread here, don't I? There's a connecting thread with b. And what if I go ahead and flip that b? And in the second inequality, say that b is greater than 2a. So it's the exact same inequality, I just flipped it, right? But then what I'm going to do is I'm going to take that and I'm going to stack it along with this other inequality that I had, right? I'll just draw it up here. But I had 5a over 2 is greater than b. And I stack these on top of each other and I look at them and hopefully I notice something. What do I notice kind of looking from this? Aha, so Joshua, I like it. B is bounded by 2a and 5a over 2, right? And in truth, you could do it this way, but you could also do it right from the beginning, because you notice that it's not a problem if I actually start from the beginning inequalities and say 5a is greater than 2b, and then stack that 2b right underneath it and say that 2b is greater than 4a, just the flip of the second inequality. So there's a linkage there. And what that really tells me is I can collapse this down into a single inequality. So I know that 5a is greater than 2b is less than 4a. Okay, so what? What exactly does that tell me? And you'll find that this is how I like to do things in the class. I like to get some participation going, so don't be shy about it. And by the way, if you want to chat me privately, that's perfectly fine as well. You can use the private part of the chat. Now, Joshua was saying A and B are positive. So let's talk about how we get to that conclusion, if that is indeed the case. I like what you're saying. And this is the kind of thing that the GRE likes to test as far as inequalities are concerned, because it's not just going to be about the mechanics, it's going to be about the logic. You're going to then have to say, okay, well, I know based on this that 5a is greater than 4a, right? Just the outer parts of that inequality. Well, if that's the case, what is true about a? Well, that's not going to work if a is negative. If a is negative, not going to be correct, right? The only way this works is if I throw in a positive number. I've got 5a is greater than 4a, and you would find that this only works if a is positive. So I know a is positive. Now, why is this of concern to us? Well, again, because this is a quantitative comparison question. The only thing I really care about is comparing A and B. That's my ultimate aim here. And what quantities am I actually being asked to compare? It's actually A plus B and 0. So it's the only concern really here is positive versus negative. Can I tell if A plus B is positive or negative? Well, I know that A is positive, right? And what about B? I mean, could I tell whether or not B is positive? And this is where the logic part comes in as well. Feel free to chat me privately or say, I don't know. Aha, Alexia says it's between two positive numbers. Nice. So I know that if I go ahead and label these, right, I know that 5A is going to be positive. I know that 4A is going to be positive, right? We said this only works if A is positive. And if A is positive, each of those other ones is positive. Well, that means that there's no two ways about it. 2B must be positive as well. So in other words, it's greater than 0, which also means by extension that B is greater than 0. So what did I just find out as a conclusion to all of this? I found out that A is definitely positive and B is definitely positive. So what does that make the final answer?
Greater than 0.
Somebody said it, greater than 0. And let's see, sorry, I'm trying to see who said that. But yes, absolutely correct. It's definitely greater than 0. There's no doubt about it, right? It's not going to work any other way.
It was IB that said that. Sorry.
IB, hey, what's up? No problem. No problem. Yeah, I like people to participate, so hop on the mic. And yeah, quantity A is bigger. So that's kind of the basic setup for how they like to test inequalities. Again, not just about the mechanics, but about the logic, being able to tell quickly which one is positive, which one is negative. And there's tons of this kind of stuff in the course. So yep, if you join my course, you'll be doing that. So what is kind of a twist on this? Okay, well, there's a couple different twists to a question like this. Because on this question, you've got not just an inequality, but you've got absolute values. You also got an exponent, which is like, yeah, right? Not only that, but check out the question stem. It says we need to indicate all such answers. And by the way, this is how it works on the GRE. If you get those squares next to the answer choices and it says indicate all, it could be that more than one is correct. And you got to find out all of them. A lot of people don't realize this going in. And it says, which of the following must be true? Now, must be true means 100% of the time, which means that, I mean, it's kind of an interesting way to think about it, but if it's 100% of the time, then that means all you need is one counterexample to show that it doesn't always work. Okay, but meanwhile, how do we do that? Because we've got kind of a weird inequality here with this exponent and also with this absolute value. So what do we know based on this? If I say that x squared is less than absolute value of x, and I want to talk about several different ways to think about this problem, but I want to see what you guys know about already. Like if I know that x squared is less than absolute value of x, what do I know, not know? What could I tell? Ah, Alexia's got a good point here. Alexia is saying that we got to think about decimals, like 0.5 or 1/2, right? And this is kind of the point of this question in part, is that one of the things they'll tend to do is they'll test your ability to think about different types of numbers. And what types of numbers do we have to think about? Alexia mentioned fractions or decimals like 0.5 or 1/2. What else do we have to think about as far as number properties are concerned? Joshua says negative numbers, absolutely. Yeah, and I find that there's usually a way around this if you know these key ranges and values. The ones you really want to test are bigger than 1. You've got, as Alexia was pointing out, those, oh, whoops, sorry, I messed this up. Those positive fractions. You've got negative fractions. And you've also got numbers that are less than -1. In addition, you also have some exact numbers that come up again and again. Whoops, I put -1. That should go down here. X should be +1 up here, and I've also got 0. Now, for this particular one, you take a look at some of those, and I'm like, okay, well, some of those are off limits. Like taking a look at this now, any that we know are just going to be out as far as the values are concerned. Alexia is saying that x is greater than 1 is out, and that is correct. How do we know? Well, all you need to do is test a quick value. Like if I did something basic like 2 squared, that's bigger than 1. 2 is bigger than 1. Is that less than the absolute value of 2, which is 2? No. So for this particular problem, I would say, all right, that's out. Ivy says x is less than, did you mean less than -1 or less than +1? -1, yeah. Okay, and again, all I would have to do is kind of test this out and say, well, if I pick a value, I would say -2, I'm going to square that. Is that less than the absolute value of -2? Well, that would be 4 is less than 2. That's a no. So right away, we've got a couple that are out. Now, this might seem like a pain when you first learn it, but the more you get used to it, the faster these problems are going to become, because you're going to be able to nail down very quickly what does and doesn't work. Okay, anything else that does or does not work? Ivy says positive fractions work. Yes. Why? Because I would just go ahead and test something like 1/2, something easy, right? So I do 1/2, and if I square that, which is what this problem asks me to do, that would give me 1/4. And is that less than 1/2, the absolute value of 1/2? Yes. So I know that this value is going to work. Anything in between 0 and 1 will work. And just to kind of skip ahead, because I know you guys can try this on your own, but if you take a look at this problem again, if you tried a negative fraction, it would also work. But what about these other numbers, like 1, 0, and -1 off to the right? Are any of those going to work? Ivy says no. Anybody else agree, disagree? Got a private chat that says no. None. Sophia says Alexia agrees. Seems like we're in agreement. Yep. None of these are going to work. Not in this particular case. 1 squared is not less than 1. 0 squared is not less than 0. -1 squared, which is 1, is not less than -1. So what did we just deduce based on this? It's really kind of cool. We just figured out that what they're telling us with this complicated inequality and absolute value is it's a really shorthand way of saying x is between 0 and 1, or x is between -1 and 0. Now that's your jumping off point once you've done this, to say, okay, well, which answers are going to fit here? Because remember, it says which of the following must be true 100% of the time. So what do we think? Which ones work? Remember, it could be more than one. So what works, what doesn't work based on these 3 answers? Now, Alexia says that x is less than 0 works. It's negative, right? But Alexia, yeah, go ahead, Ivy.
I think only x squared less than 1 works.
Okay, so what does that mean about x is less than 0 then? Why doesn't that work?
Because x is less than 0, that means it's negative, but it also includes the integers.
It also includes integers, yep.
So -2, -4, all those don't work. So that is not always true. It's true in some cases, but it's not always true.
And it's that last part that's so important, that not always true. And what Alexia was saying, I think one of the reasons I like to do this question is because you could very easily forget the wording of the question. That's what they like to test. It says must be true, right? That's why I bracketed or boxed it, right? Does it have to be true? Sure, x is less than 0 could be true. If it said could be true, then it would be in. But that's why I put this little note at the top right, the idea that all you need is one counterexample to show that it doesn't always work. Well, x is less than 0, no. X could be positive. Positive fraction, no worries. Like I say, make your mistakes here. You don't have to impress me, you have to impress the test. So make your mistakes here. No judgment at all. So that's no good, right? Meanwhile, with the second one, so if x squared is less than 1, now what you can do with that is you could break that down and say, okay, well, this literally means, by the way, that x is in between 1 and -1. If you think about it, that makes sense because 1 and -1 are the boundary points, right? -1 squared is +1, 1 squared is +1. So they're really telling you there that x is between -1 and 1. Does that have to be true? Well, yeah, because if I take a look at the inequalities I found at the top, no matter what fits these two right here, x is always going to be between -1 and 1. So this does have to be true. And what about the third one? Okay, well, it says that the absolute value of x is an integer. Now, try to demystify things as much as possible, because what I could do there is simply square both sides, right? And what I would get is basically that x is an integer squared, or x is a perfect square. So some number squared. Now, does that have to be true? Got a yes, got a no. Well, the truth is that not only does it not have to be true, it turns out that it's never true. Because what do we know? We know it's between -1 and 1, like the second one here. If it's between -1 and 1, we know for a fact, by the way, that x is not even an integer. And this is the kind of logic-based thinking that they like to test, right? If x is between -1 and 1, it's never going to be an integer, right? Because we know 0 is not included. If 0 were included, that would be a different story, but it's not included here. So never going to be a perfect square. And it turns out that the only one that's in play is that second one. So this happens to be one where only 1 is the correct answer, but it could be more than 1. It's because it says indicate all such answers. And I want to pause here to see if you guys have any questions, because I know that was quite a lot. Try to get through a lot in this hour. Questions, comments, concerns, smart remarks, life musings?
I think this is usually my problem. It's the trap answers. Like the x less than 0.
Yes.
You do a quick calculation and you find, yes, it works for x less than 0, but then it's not always true. And
Yeah.
then and you lose the point for the whole question.
Exactly. And that to me matters more necessarily than, some of the really hard questions. I think people get obsessed with doing super difficult questions, and people forget to shore up the basics and forget not to misread a question, right? Making sure you're absolutely clear on what the question asks. Yep. And you're certainly not alone. All right. Cool. We'll move on to the next one. And let's see which one we're going to do next. I'm actually going to skip ahead a little bit because I wanted to do a little bit more with absolute values, but this is another quantitative comparison question. And it looks kind of intimidating when you look at it, right? Because they tell you here, they give you crucial pieces of information. They say m is not 0, n is not 0. Okay, great. And then, absolute values on both sides? I don't like that. That's meant to kind of intimidate me, right? And the quantities I'm being asked to compare, if I take a quick look at that, is the product of mn and 0. So I size this up a little bit. And what I want to do is make note of the fact that This is what I care about with the quantities, right? Always keep in mind what I like to call the question part of the question. Sounds redundant, but it means never forget what you're trying to do in the first place. We're trying to compare the product of mn to 0. And you can get lost in the problem and forget that that's your goal here. But first things first, of course, because how do we deal with this inequality, or sorry, equality, right? This absolute value with absolute values on either side. Okay, any thoughts to get us started? Or like I said, always I don't know is a perfectly acceptable answer. Yeah, okay. Ivy says, first thought is to try to do what we did in the last question. Absolutely. And yeah, Alexia is saying plug in possible numbers. Now, that is a perfectly valid strategy. It's not necessarily a strategy you want to use every time, but it is a strategy you can use to your advantage just by plugging in some quick numbers and seeing, okay, well, what would make this work? Now, the problem is if we're going to plug in numbers, what kind of numbers are we going to plug in? And can you give me some examples?
I'd stick to. I don't think it matters positive or negative just based off of the absolute values. So I'd probably pick a whole number, a fraction, and see if that changes anything. I'll
Sure.
start
Yeah.
there.
And yeah, absolutely. So this is absolute value, right? So your thought immediately should be to try positive and negative numbers because they both could be valid. Now, what if we do what Ivy just said and plug in some easy numbers? So let's say we deal with just with integers. Let's forget about fractions for a moment. What are we going to do as far as integers are concerned? Can we plug in a couple of easy examples for m and n? And if so, what would they be? Sophia says 1 and 2. Why not keep it simple, right? Now, my personal philosophy, and there's no way you could have known this, Sophia, that's actually pretty good. But what I personally like to do is I like to avoid 0 and 1 because they have identity properties. And that means you could possibly get repeats in the answers if it's a multiple choice question. So as a rule, I kind of like to avoid 0 and 1. Yeah, but let's tweak what Sophia did and say, like Alexia's saying, let's just do 2 and 3. Why not, right? And so we would look at this and we would say, all right, 2 plus 3 equals 2 plus 3. Is that true? Well, on the left side, we would get a 5. And on the right side, we would also get a 5. So this checks out. So it could be that we have two positive numbers like this. All right. And Bagambaki is kind of jumping right to the conclusion, see if this is correct. But yeah, we plugged in two positive numbers. We got 2 and 3, right? And then we could say, okay, well, let's turn the tables a little bit here. Now, I'll kind of cut to the chase here because one of the things that it turns out doesn't matter as much, fractions are not going to matter as much here because really it's all about the positive versus negative part. If you were dealing with inequalities and exponents, you would want to consider those. But here, what about something like this? What if I make one positive and the other negative? And I look at this and I say, okay, well, is this going to check out? 2 plus -3, that's -1. And I take the absolute value, that's going to be 1. And what do I got over here? Is that equal to 2 plus the absolute value of -3, which is 3? Uh-oh. That's a big no. Okay, one more thing to try here. I made them both positive. I made one positive, one negative. So the only other thing to try here is what if I make them both negative? Oops. Is this true? And on the left side, I would get -5, absolute value of that. That's +5. Over here, I got 2 plus 3. Hey, looks like we got a winner here too. So the two situations that end up working are right here, right? Where we made m and n 2 and 3 and -2 and -3. And your job after doing this is to say, okay, well, what conclusion can we then make about m and n? Henry's got one idea. That's being echoed in the private chat. Yeah. Sophia, IB, so you guys are jumping right to it, right? And what they're saying here is, what does this all mean? Okay, well, after kind of walking all through this, I realized that what this tells me is m and n have the same sign, meaning they're either both positive or they're both negative. And the little number properties comes into play here, right? Because the question part of the question, again, I go back to what I wrote in the top left. It's about the product of m and n. Okay, well, whether I have two positive numbers or two negative numbers, the result is going to be exactly the same. Yep, Alexia got it, right? You're going to get a positive product no matter what. And the problem is you could look at this and say that they have the same sign, but I don't know if they're positive or negative. And you can falsely conclude that the answer is D here, even though you want to have that in the back of your mind. But it turns out what we care about is the product, which is always positive. And we're comparing that to 0 over here. So final answer has to be A. Pretty nifty, right? So hopefully that gives you a good picture of kind of how they like to test the inequalities. And we're going to switch gears here and go to some critical reasoning, but I wanted to pause to see if you guys have any general questions about this or anything else related to inequalities or absolute values. And was this helpful, not helpful? All good, Alexia says, excellent. Helpful, good. And to kind of do the critical reasoning stuff, I just wanted to give you kind of a window into the basics, nothing too extensive, but this is the stuff we'll be talking about in the course. And actually, did I skip one over here? Nope, I did not. Okay, so let's talk about how critical reasoning works, because what you're really asked to do in critical reasoning so really quick, Bogdan Bahi is saying, remember, so on the question, you wouldn't choose 0. It actually did specify that neither m nor n is 0. It specified that in the conditions at the top. Okay, so when you're doing an assumption question, which is kind of the basic building blocks here, I wanted to kind of open up the floor for discussion here before we actually do this question. Assumption. Now, what do you guys know about assumptions? What exactly is an assumption, especially in the context of the GRE? Kind of quiet, huh? Well, you can think of an assumption as there are a few different ways to look at it. An assumption is something that the author, or I'll say arguer, because it's not always the author, must believe in order for the argument to make sense. You can also think of it as a bridge between what are called premises and conclusions. And what's the difference? Well, the conclusion, the ultimate judgment call, that's going to be more like a judgment or opinion, right? And a premise is sort of a statement of fact. We don't really care whether it's true or not. We just care how it's presented to us. And our job is to step in and say, okay, well, what does the author have to believe that's missing here? And we can kind of look at this one as a basic example, right? And we have to pay close attention to the wording, right? And a good idea is to kind of get an idea ahead of time of what the problem with the argument is. Nothing too specific. You don't want to waste a ton of time thinking about it ahead of time, but you do want to get an idea of where it goes wrong. So to kind of get the party started here, it says, okay, without a sufficient dietary intake of vitamin B12, humans will develop vitamin B12 deficiency. So that is basically a premise. It's stated as a fact, and it's kind of background information. We don't know really what the context is there. And then it says vitamin B12 is found in high concentrations in red meat. Okay, another premise. Therefore, key conclusion language, right? We see that word therefore, definitely going to get to a judgment or opinion. To prevent vitamin B12 deficiency, humans must eat red meat. And that's a little blocked off, so I'm going to underline that instead. Humans must eat red meat. So if we look at this right now and kind of think about the argument, is there anything you see wrong with that or any kind of gap in logic that might be, important here?
I think, sir, what I found was, I think there could be there's obviously vitamin B12 found in other foods. So to assume that red meat is the only way, the only way you can get B12 is a big assumption.
And Derek's absolutely right here. Derek, question, what made you think about the word only? Is there any wordage that was used in the conclusion that kind of gives that away? I mean, you were correct.
Yeah, I guess the word must.
Mm-hmm.
Yeah, the word must.
A lot of people are, yeah. And believe it or not, a lot of critical reasoning questions are like this. It may hinge on a single word or phrase, right? Not always, but it can. And the difference here is that in the conclusion, the author is saying must eat meat. In other words, there's no other way, right? I know vitamin B12 is found in high concentrations in red meat, but does that mean I have to eat red meat? And I can think about this ahead of time and say, okay, well, what is the general thing that the author is assuming here? And Derek actually hit on this. So Derek or anybody else, what is the basic thing the author is assuming?
Only one source of vitamin B12?
Yeah. Mm-hmm. So you could phrase it in a lot of different ways. The assumption here is that there's only one source of B12. You could also say, okay, there's no other source of B12, right? And this one's pretty straightforward, right? But you notice how I'm making things very broad, right? This is very broad, not too specific. It doesn't actually mention any other specific source. I'm not going to get into that. I just know that the author's assuming there can't be another source. And I want to find the answer ahead of time that most matches that. And what this process is going to help you do is get rid of answer choices that clearly don't do that. And this is where I'll open it up to you guys. So take a look at some of these answers and tell me not only if you found the winner, but if you found some clear losers, like answer choices we can toss out pretty much immediately. Okay, Henry's jumping right to A. Alexia and Ivy are both saying B is a big loser, which I agree with. Because if I look at B, first of all, check this out. It says some plants. Now, I personally like to point this out because quantity words can be very suspect. And they're not always wrong. But when I see a word like some, what I want to think about is the idea that that means just at least one, right? It could be one or two plants, could be a billion plants. So the ambiguity is suspect right away. Again, that's not to say it's always wrong, but I want to dive into that and say, well, is there a problem here? So some plants actually do contain high concentrations of B12. Well, okay, great, but The problem here with answer choice B is I don't have to assume. Remember, I said in the top right, it's something the arguer must believe. The author doesn't have to believe anything about plants. Doesn't have to believe that this is definitely the source. C, irrelevant, and I like the word irrelevant. I think I like, so Alexia's saying irrelevant. Some people like to use the term out of scope. I think that's kind of dangerous because answer choices will always sound out of scope because they're new information. It will necessarily be new information. The question is it relevant or not? So how B12 is degraded, I don't care. Nothing to do with this bridge that I'm looking for, this whole idea that there's another food source out there. Yeah, now Sweeta or Sweta, tell me if I'm getting it wrong. But yeah, saying that E is kind of going in the opposite direction. So because consumption of red meat can cause many problems, well, if anything, that makes us think we're going in the wrong direction because we're saying humans must eat red meat, right? But going back to my quantity thing, I think it's kind of cool to point this out. It says many people avoid consumption of red meat. Question, how many people is many? What do you think? How many people is many? Lexi says 100, maybe. More than 3, maybe. Hasn't been quantified, Ivy says. Not only that, but okay, many, you can quantify that in different ways, but isn't it possible, a lot of people don't miss this, it doesn't say most. Now the word most means definitely greater than 50%. But if I just say many, for all I know, that could be 1%. It could be 99%. Right? Like take the world population, which is about 8 billion. So 1% of the world population is 80 million people. I would say that that's many, 80 million people. Does that mean it's the majority? Not even close. So the idea here is that, okay, well, some group of people avoid consumption of red meat. Great. I don't know what this means in general. Right? And as Sweta was pointing out, E is going in the opposite direction anyway. So we got a lot of answer choices that we've killed off. We've got B out, we've got C out, we've got D out. Yeah, now D is a tempting answer choice to a lot of people because you see the idea that vitamin B12 deficiency can cause a variety of health problems. Now, what you want to do is look out for answers that point to the wrong conclusion. Sounds tempting because in the real world, what this would make me say is that, okay, well, if it can cause a variety of health problems, what does this do? Confirms that vitamin B12 is important. And that's why a lot of people would go for D, believe it or not, because they say, oh, well, vitamin B12 is important. That sounds pretty good, right? Not what we're after, right? This conclusion is about whether or not humans must eat red meat. And I already know that vitamin B12 consumption is important. So if anything, that kind of just confirms something I already know. And that just leaves us with A. And the wording is kind of funky, right? You see these double negatives flying around everywhere, but human beings who do not consume red meat could not prevent vitamin B12 deficiency by using another source. Now, the danger here is that you look at that and see vitamin B12 supplements and you're like, that is out of scope. This is why I don't like out of scope. It might be out of scope sounding, but the problem is it's the correct answer because in a general sense, what this points to is another possible source of B12. Right? And that's it. Right? Pretty much as simple as that. Any questions about this one before we try one more of these? I think we'll have time for one more. And even if you got this one in general pretty quickly, it's still valuable to go over all these things we've done for harder questions, like picking out little bits of language like some or many. the idea that the conclusion says must eat red meat. So I would like you guys to try one on your own. And I'm not going to say too much. And I want to see how you guys do with it. Okay, so let's see what you guys with this one, do with this one, excuse me. We'll come back in a couple minutes. Good luck. Oh yeah, I forgot to say, sorry. If you want to type in your answer into the chat, so I know you can do it privately, click on the private chat to me and you can just type your answer in privately. All right, let's come back. And this is about the time frame you want to use on these questions, right? It's not a lot of time, but you get better at them as you try them. So go ahead and type in what you think the correct answer is, either publicly or privately. And we will be back in 5, in 4, in 3, in 2, 1. All right, let's do this. Yeah, so it's a little bit interesting. I'm stumped. So let's actually try to map out the argument a little bit. And this is why I think it's so important. I mean, I think people have a tendency to take kind of furious notes right when they read it, but I like to kind of read the argument through first and kind of try to digest it. So it says the most effective way to increase the productivity is to limit their distractions. Okay. So that seems like kind of a background piece of information. Let's see if that's the case, because it does sound like it could be a conclusion. It could be a judgment, but we'll see. The main source of distraction of our office employees is the internet. Starting next week, we will no longer provide internet access to employees working in our offices. Now, this is what I like to call, I purposely didn't tell you guys this ahead of time, but some questions take the form of what's called a plan goal, which means instead of your standard premise and conclusion, there's some kind of goal we're trying to achieve, and we've got a plan to do it. And here we kind of have an outline of, okay, here's our plan. We're going to eliminate, so get, and you can phrase it any way you want, right? I'm just doing it in one way, but get rid of internet access, okay, to employees. And what is the eventual goal here? And what are we saying will actually happen? And it says increase. Well, some people like to do this. I personally like to do this too. Little up arrow for increase, remind me that I'm going in that direction. And it's about productivity. That is the goal. I want to increase productivity. So I'm getting rid of internet access. And what I could do is stop there and say, well, why is there an assumption being made here? It seems like a solid argument when I first look at it, but I want to take a look at it and say, why might that not be the case? Play devil's advocate, right? Put on your debate hat, like you're on a debate team, and say, I don't trust you, right? Look at the conclusion and say, I'm going to actually pick at this and say, well, maybe the opposite is true. This is what I personally like to do. Think of it as trying to weaken the argument. And what a weakener would say, okay, yeah, no internet access, maybe somehow that either keeps productivity the same or even decreases it. Right? Just because it doesn't go up that means it goes down. It could stay the same, but it could very well decrease. So what I'm assuming in a very general sense is a connection between this idea of internet access and productivity. Like, get rid of it and I'm going to increase productivity. But what if I actually take it away and somehow productivity goes down? Now that will help you at least get rid of some answers that are like out. So now knowing this, how we just mapped it out, any answer choice that you look at now that you might have thought about before that you go, nope, it's out. And I can get the party started kind of by going one by one. We look at the top, right? And I think people forget about this. For efficiency's sake and to get your psychology or getting like a little psychological boost, start picking off wrong answers first. I look at answer choice A and it says, okay, some Bright Star office employees are not distracted by the internet. Okay, I look at that word some and immediately what do I think about that word some? What did I say in the last question that means?
It's too subjective, just like the word many in the last example.
Yep. And there was also the word some in the last example too. And what I said about the word some, so Derek's absolutely right. Some means could be one person, one employee, or it could be 1,000 employees. And that's enough for me to really think about this and say, okay, well, suppose I find out that one employee is not distracted by the internet. So what? That's not going to tell me anything one way or the other about overall productivity of the company and whether internet access has anything to do with it. Okay? And yeah, in this case, some does not have to mean less than 50%. It could be more than. Really the translation here for the word some, when you think about it, is not zero. It's anything that's not zero. Okay. Second one, Bright Star does not provide any of its employees with laptops that can be used at their homes. Great. So we have these laptops that can be used at their homes. What does that say about productivity, one way or the other? Nothing. I can fill in that in my own mind, right? And say, oh, they can use it, they can use it at their home, so maybe they'll be more productive. But that's kind of filling in a gap that goes too far according to this question. Okay, answer choice C. Office employees at Bright Star are on average very productive. And among other things, what I told you about an assumption is that it's something the author has to believe. So must the author or arguer believe this? Does the author have to believe that office employees are on average very productive at this company? Any takers? Ivy says nothing. Oh yeah, go ahead, sorry.
Yeah, I was just going to say, I don't think so. I don't think the author has to believe that on average everyone is very productive, because I think the premise of the statement is increase in productivity. So it could be from 2 to 10 or from 3, we don't know, but there's just going to be an increase. So I don't think, this has to be true. This has to be a belief. That's what I think.
Correct. Foodman is absolutely right? This is just about increasing productivity, right? I'm just trying to increase productivity. So do I have to start from a point of being very productive? No, the author doesn't have to believe this. Not only that, but Alexia is making a very good point in the chat. If he did believe that, would he actually be initiating this plan? Probably not, right? Kind of goes against it, right? The need to increase productivity if they're already on average very productive, right? So we wouldn't need the plan. And this is the kind of thinking that the test prizes, right? It's a little bit difficult to get used to, especially in your real world brain, because you're trying to like bring in all kinds of outside information, but you want to really limit yourself to what the argument says. Don't bring in outside information. Okay, and answer choice D, it is not impossible for Bright Star office employees to be productive without using the internet. Okay, now, this one is interesting because it talks about this whole idea that, okay, impossible to be productive without using the internet. And if we take the language and we twist it around a little bit, it says not impossible, right? So if we change that to just say possible, yep, Alexia, you got it, right? It becomes possible. It is possible for Bright Star office employees to be productive without using the internet. Now we've got our connection between, as we saw in the top right, internet access with productivity. And what does that mean here? Okay, well, if the author is saying that productivity will go up necessarily by getting rid of the internet, the author has to believe that the internet, I mean, basically another way this is saying, it's just picking apart the language, that's the toughest part, but the internet access isn't necessary for productivity. Because if I find out that it is necessary, well then if I get rid of it, that would indicate productivity would go down if I get rid of something that I need for productivity. And that's exactly what our weakener said, right? So it goes the opposite direction of our weakener. This one's looking pretty good. And answer choice E, could not increase productivity by providing better training. Well, that's a different method of possibly increasing productivity, but this is kind of a classic wrong answer where it's all about, okay, well, there might be a better method, but what about this method? Just because there's a better method out there doesn't say anything necessarily about whether this method will be effective. I just want to increase productivity. I could still do that without using the best method. Classic type of answer where they try to sucker you into picking something that's just a better method. So it turns out D is our winner. And that's a wrap. Cool. Feel free to ask me questions after we're done, but I wanted to get this little obligatory promotional thing up here. So the class is now discounted. Instead of $13.99, it is $9.99. Limited seats available, so join. Glad to hear it was great, Alexia. I like the positive feedback and negative feedback too. Anything that helps me learn. Class is starting on Tuesday. You get 40 hours as part of the class. You also, and this is crucial, this second point, you get access to the TTP self-study course at no charge. So that's 6 months of access. That's a $399 value. You can get it as part of the course. And we also have a Slack channel that you can use to kind of communicate with me and other students during the class. And what I also wanted to do is get this information on how to sign up. And I'm just going to put this into the chat because it'll be easier for you guys to just copy the URLs. I will put these in here now. You've got the landing page, just the basic one for LiveTeach. There it is. The registration place for online classes, and also different plans that you can access. Feel free to copy those links and go to them now. And yeah, feel free to copy those links and take off if you need to go, but I'll stick around in case you guys have any basic questions before we wrap things up. Questions, comments, concerns, smart remarks, reflections, positive or negative? Thank you, Ivy. Great, good. Glad to hear it was helpful. Funmi, you're welcome. Yes, good luck to everybody, as Alexia says. Brilliant. Okay, I'll stick around in case you guys have any questions for a few minutes. Sweta, yep. Sweta, sorry if I get that wrong. And have a good rest of the day, everybody. Hopefully, I will see some of you on Tuesday. Take care.